Hello, I am recording this video for part 2 of my Statistics 110 exam. I will be starting with Exhibit 1, which has us look at a study where it discusses that a recent medical study talks about how people who eat fast food have 120 beats per minute for their heart rate, and the person who doesn't eat fast food has 75 beats per minute. Because of this, scientists say that that's how fast food leads to heart disease. This may or may not be true. Now, the reason the scientists may say this is because of causation, but unless we take the proper steps to look into this, we may miss out on some working variables. The heart disease could be due to a family history that without looking further into this, we won't understand. With human inference, we often just assume that what we're told is true because we haven't done any research to look further into this. So this kind of leads us to wonder, is everything that we read true just because a scientist says it? In the second study, a scientist goes back over that data and they decide that they are going to look into a group of 200 people and find out if this is in fact the case. At the end of their study, they say that the people who ate the most fast food were the ones who ended up with heart disease, and eating more fast food causes heart disease. This, again, may cause some issues. It includes some slippery evidence because there were no established control variables. So we don't know what is true and what's not true because there was nothing said to decide that this group of people would do one thing and another group of people do another thing. So without a controlled variable, there's no proper way to gauge whether one person had more fast food than the other because we're simply collecting data from a survey that people have filled out or turned in information on. In Exhibit 2 of the exam, we see the definition of correlation, which is a linear connection between variables. It's a connection that can be seen as quite obvious. It just is something that you don't really have to search for. A causation is something that is a connection of cause and effect. One variable may lead to another variable's effects. So something, if I push someone, they're going to fall. That is cause and effect. I won't be pushing anyone though. In section B, we talk about correlation coefficient. The correlation coefficient is an important way to quantify data by taking a plot like this, or you could have one like this, or you might even have one like this, and taking that scatter plot and organizing that data to show whether there is a correlation or where there's not, whether there's a relationship between the evidence collected or if there's no connection at all. We also want to talk about two variables with no causal relation. So the two variables that I'm choosing to discuss are going to be residents of a neighborhood closing their blinds and the sun going down. Now, just because they close their blinds at the time that the sun goes down does not mean them closing their blinds causes the sun to go down. It's actually usually the opposite effect, that the sun going down makes them want to close their blinds, but it's not directly related at all. A clear causal effect with two variables. This one, I don't know why it came to mind, but flushing the toilet. If you push on the handle at the toilet, there's a mechanism inside the toilet that causes it to flush. If you don't do that, then it's not going to flush, which leads you to believe that pushing on that lever, connected with all the other gears inside of the toilet, make that flush. Why this is important when we're looking at the evidence is because there may be a lurking variable. Inside that toilet, there are other things that work together. And if we don't know about those other things, then we could just assume that any metal piece that's connected to the toilet, if we push on that, it will cause it to flush. So taking the proper steps to know what a causal variable or a causal relationship and what's not a causal relationship are very important when we're looking at slippery evidence. Thank you.